Okay, so what we discussed last class is bijection. So what is this bijection? If a function is both 1 1 and 1 2, f maps a to b. F is a function from a to b is both 1 1 and onto. That is injection and surjection. Then it is called bijective function. And for onto function, what is the definition? For onto function, I am giving another definition which is same, but mathematically what you can write. So f is a function from a to b such that f is a function from a to b such that for every y belongs to b, for every y belongs to b, whatever element if you take from b, there exists, this means there exists x belongs to a such that x belongs to a such that f of x equal to y. That means, or you can write like this, or yeah, this if you take this side, no, x equal to f inverse y. First time I'm writing f inverse y. Now you understand what does it mean. Onto function, yesterday I told f is a function from a to b such that for every element in b there exists x belongs to a such that f of x equal to y. What does it mean? The image of x is y. That means for y there exists pre-image x in the set a. So that's what I told. So pre-image of, so here x has pre-image y, sorry, y has pre-image x. It means f inverse of y equal to x means, here this means what? Image of x is y. F of x equal to y means image of x equal to y. F inverse of y equal to x means simply it's called inverse image or pre-image. I already taught you pre-image. Now this is a and this is b. Here x is there, here y is there. Now if it is associated like this, x is associated with y or x is related to y like this, then x is pre-image and y is image of x. How do we write this one? We write this f of x equal to y. We are writing, that means image of x is y. I already told you image of x is y, we write like this. Now pre-image or inverse image, both are same. So f inverse of y, if you take that side, you can understand like that, f inverse of y equal to x. That means pre-image or inverse image of y is x. Inverse image of y is x. So now what I am saying here, f is a function from a to b such that for every y belongs to b, that means every element in y, there exists a pre-image in a. See, every element in b, there exists a pre-image in a. Then what we say, f is onto, the same thing I told yesterday. So now here what is the condition? Number of elements in a must be more than or equal to number of elements in b. Okay, this is the condition I told for onto function. Okay, so then what is bijection? 1 1 and onto function. You have to check both 1 1 and onto. And what is the note for bijection? What is the note? N of a must be equal to n of b. N of a must be equal to n of b. That's what is the note for bijection. So this is what we discussed. Now we'll discuss two more important functions. So now here, see, real functions. Okay, real functions. What does it mean, real functions? Now f is a function from a to b. Okay, f is a function from a to b. If a is subset of real numbers and b is subset of real numbers, then what we say? Then f becomes a real function. Okay, f is a function from a to b such that a is also subset of real numbers, b is also subset of real numbers, then f is called a real function. So okay, so now this among these real functions, types of real functions, types of it. So first one is constant function. So everybody should take this notes. Constant function. What is this constant function? F is a function from R to R. F is a function from real numbers to real numbers. Defined as, how it is defined? Always it is defined as f of x equal to some constant. f of x equal to some constant. Where what is this constant? Any real number. So that means here this I'm just giving rough idea in arrow diagrams. So this is all real numbers. This is all real numbers. Understand? Here now let's say this is c value is some 10. So here 1, 2, 3, 1 by 2, 1 by 5, 1.5, 2.5, whatever, so many. All are connected to 10 only. Though here you have -1, 0, 1, so on. So many is there. But everything is connected to C only. So that means here, for example, f is a f of x equal to, let's say I wrote here 10. So f of x equal to 10. That means what here? So f of 1 also 10, f of 2 also 10, f of 3 also 10, f of any number. See, f of x equal to c for all x belongs to R. So in the domain for all, whatever x you take in the domain, whatever real number you take, its image is only c. C is constant. So f of 3 is also 10, f of 4 is also 10, f of 5 is also 10. So that is how f of x is 10 for all x belongs to R. Whatever x you take, you get only 10. So how is its graph? So graph is like this. F of x equal to 10. F of x equal to 10 for all x belongs to R. The graph is like this. Real function, so constant function graph is like this. F of x equal to 10. F of x values we take on x-axis. 0, 1, 2, 3, some points. For 0, so 10 may be here, 10 is here, I'm taking on y-axis, 10 I'm taking here. So for 0 it is f of 0 also 10, f of 1 also 10, f of 2 also 10, f of 3 also 10. See, 0 comma 10 is here, 1 comma 10 is here. So f of -1 also, -1 is also 10, -2 also 10. So graph will be like this, you know this one. So y equal to 10 is parallel to x-axis, parallel to x-axis, parallel to x-axis. Graph is parallel to x-axis. Very simple. So then another example, f of x equal to, let's say, minus some 152. Let's say f of x equal to -152. So how is this graph? Graph is same thing. So here 0 also -152. Here let's say this is -152. So this 1 also -152. 2 also is all like this. The graph will be like this. That means this constant function, graph of constant function is parallel to x-axis. So that is constant function. Hope sufficient discussion so happened. So here, what is the domain? What is the domain? Domain means, you know, all real numbers. What is the range? Range is only singleton set. Singleton set. In this case, -152. The above case range is what? Above case only 10. Singleton set. Only single element will come. Obviously, now only your range is what? Always constant. C is the range. So this is what is constant function. So then we'll go to identity function. Next, real function. Second one, identity function. Identity function. What is this identity function? F maps all real numbers to all real numbers, defined as f of x equal to x for all x belongs to R. So that means, what does it mean? F of x equal to x only. Identity. Identity means what? If you see your face in the mirror, you will get your face only. So that means f of 1 is 1, f of 2 is 2, f of 3 is 3. Like identity relation we studied. Identity relation we studied. Similarly here also, f of x equal to x for all x belongs to R. That means what is identity function? The graph is like this. So here for 0 it is 0, for 1 it's 1, for 2 it's 2. In between 0.5 it is 0.5, like this. The graph will be like this. If you know, it says y equal to x. F of x means y only, because f of x value we take on y-axis. Therefore, y equal to x is a curve we get for identity function. What is the domain? Domain is all real numbers. What is range? Range is also all real numbers. So this is identity function. So you understand identity function. Let's say IA. IA means it is represented like this. IA. That means I is identity function. Where to where?
Sir, example.
A to A. Identity function is like this. IB means what? Identity function from B to B. Okay, this is the identity function. Okay, so okay, all right. So then we'll go to some exercise. Okay, identity function. What does it mean? Identity function meaning. So here, whatever number you take here, f of x equal to x, na, for all real numbers, whatever real number, 0 image is 0, 1 image is 1 only, 0.5 image 0.5, 0.3 image is what? 0.3 only, 0. Like that. If you take now 2, its image is 2 only. If you take 5, its image is 5 only, like that. So here IA, if I is identity function from A to A, we represent with IA. If I is the identity function from B to B, we represent from B to B. But in general, identity function is represented. Identity function is defined from real numbers to real numbers. Very simple. So identity means what? If you see your face, identity, na, X image is X only. For all X belongs to R. Whatever real number you take, you will get the same image. Very simple, na? So this identity function is both 1, 1 and onto. Both 1, 1 and onto. Why it's both 1, 1 and onto? You see, here if you take -1, 0, 1, 2, you will get same, na? -1 image, -1 only. 0 image, 0. 1 image is 1. 2 image is 2 only. 1, 1 and onto. Both 1, 1 and onto. Different elements will have different images, and every element have pre-image. What is the pre-image? Itself. Every element has pre-image. What is the pre-image? Pre-image is the number itself. All right, so that is identity function. Now we'll see then next equality of function or equal functions. What is equal functions? Now two functions are said to be equal. F comma G are two functions, na? F and G functions are said to be equal. Two functions are said to be equal. Okay, when here two conditions. If, first condition, if they have same domain, they have same domain, they have same domain, or they are defined on the same domain. They have same domain, or they are defined on the same domain. Both are same. What is the first condition? Having same domain. Same domain. That's the first condition. What is the second condition? Second condition is f of x equal to g of x for all x belongs to the domain. For all x belongs to the domain. So here, if you take in the domain, if you take some number, both should have same image. Okay. So for example here, equal functions. Example is now here. F is a function from A to B. Let's say 1, 2, 3. Here A, B, C, D. So here 1, B, 2, A, 3, C. Let us say this is F is a function from A to B, and now G is a function. G is a function from A to C. Let us say. So here 1, 2, 3. Here A, B, C. So now 1 to B, 2 to A, 3 to C. Yet what are the two conditions? Same domain. What is the same domain? A is the domain. Same domain is there. Okay, no problem. Now f of x equal to g of x for all x belongs to D. In the domain, if you take f of here, f of 1 is what? F of 1 is here also A. Here g of 1 is what? G of 1 is here. G of 1 is what? G of 1 is also B. F of 2 is what? A. G of 2 is what? Is also A. F of 3 is what? C. Here g of 3 is what? Also C. So what you can say now? F of x equal to g of x for all x belongs to domain. So they should have same domain, and in the domain for each element the images should be same. Image of x under f in this function for each element in the domain, each element in the domain should have same image. See, like this, f of 1, g of 1, both are equal. So that means in the place of x I put 1. So f of 1 equal g of 1. Then next element 2, f of 2 equal g of 2. Next element f of 3 equal g of 3, like that. So then these two are called equal functions. So now I am giving a next example, one more example. Let's take one more example. Now here if I take, for example, let's take this log x cube and 3 log x. Both are equal functions because already I taught you logarithms. I am telling this. Log x cube is equal to 3 log x. Why? These both are equal functions. How do you know? Because here x is a positive real number. Already I told you this one. X is a positive real number. X is a positive real number. Okay? And x is a positive real number. And here also x is a positive real number. So domain is same. Domain means x value. No? Domain is same. They both have same domain. Number one. Number two is here f of x equal to here g of x. G of x for all x belongs to R. See, you're able to see. I think 3 will come front. So they will have both will have same image. Same image. So therefore these two are called equal functions. So then I'll give the example where it is not equal. So now let's say log x square and 2 log x, okay, are not equal functions. Not equal functions. Why they are not equal functions? You know, your domain of this domain is what, you know, here for this domain is x is for this domain is x can be any real number. X belongs to any real number except to 0. Even negative number also there. If you square it, it will become positive. Therefore, domain is all real numbers except 0. Here, what is the domain? Domain is only R plus. Or here in this case, domain is R plus means what? X belongs to R plus in this case. What does it mean? X belongs to 0 to infinity. Here, what is the domain? Minus infinity to plus infinity except to 0. So therefore, they are not equal functions. Okay, so they are not equal functions. So hope you got this one. So this is log of this is not equal to this because this is not defined and this is defined. So therefore log x square and 2 log x are not equal functions. Okay, if at all you have to equate, there is a condition. Log of x square equal to, you can write 2 log x only when x is greater than 0. If x is greater, when these two are equated, you should understand x is greater than 0. That's what you need to understand. So here this is a question. If f of x plus y, f of x plus y equal to f of x into y for all x comma y belongs to R. So here x and y both are real numbers. You can take any real number. Then prove that f is a constant function. So now x and y can be any real number. Now first thing I am taking is x equal to 0 I am taking. If I take x equal to 0, and also of course if you take x equal to 0, y equal to, you can take 1. You can take y equal to 1, you can take. So then what will happen here? F of 0 plus 1, you substitute x equal to 0, y equal to 1. F of 0 plus 1 equal to what? F of 0. So that means what I got here, f of 0 equal to what I got now, that implies f of 0 equal to f of 1 I got. Okay, all right. Number 1. Number 2. Now what do I do is, f of, here I'll keep 1 plus 1. That means what? X is 1, y is 1. That means f of 2, na? F of 1 into 1, you get like this. That means what I get now, f of 1 equal to, that means here f of 1, this is f of 1 equal to f of 2 I got. Similarly, if I put f of 1 plus 2 I keep, that means what will happen? F of 1 into 2, that means f of 2 equal to, I get f of 3. So like that you can prove, f of 0 equal to f of minus 1 also you can prove. Then everything are equal. That means f of minus 1 equal, f of 2 equal to, f of 1 equal to, f of 3 equal to, f of 4 equal to, you can keep all. What does it mean? Everything is equal only. What does it mean if everything is equal? All are equal only. That means if you keep here minus 1, minus 2, 0, 1, 2, in between so many numbers, 3, everything will have same image only. What is that image? F of 0, let us say f of 0 is some constant k. F of 0 is k, then f of minus 1 also k, minus 2 also k, 1 also k, 2 also k, 3 also k. You are seeing all will have same image. So every element you can show, any real number you take, you will get same image. What does it mean? Same image means what?
Equal function.
Constant function. Constant function, na? Constant means what? Domain. See, constant means for every element, you will have only constant image. So constant function what? That's what we discussed, na? Constant function. So what is a constant function you see? F of x equal to 10. F of 1 also 10. F of 2 also 10. We discussed, that's what we discussed. F of 1 10, F of 2 10, F of 3 10. Everything will have same image. Only one image, singleton image, na? Singleton set, na? So that's what here. F of 0 equal to F of minus 1 equal to F of 2. Whatever you take, we can prove all like that. So F of 3 we proved. Like that, now F of minus 1 plus, let's say, minus 1 plus here plus 1, let us say, equal to what? Minus 1. This is f of 0 equal to f of minus 1. So you see, everything will have same image, only one image. Everything, image of minus 1, 0, 2, 1, 3, 4 is same, equal. That means what? It is a constant function. That's how we have to prove. So next question. So this is the question. For answering this question, first you should know one formula. What is the formula that you should know? Is cos 2 theta formula. What is cos 2 theta formula? So then only you can understand. Cos 2 theta formula is cos square theta minus sin square theta. That is the formula for cos 2 theta. Okay, then only you can understand this one. So now f of tan theta, equal to what you get? 1 minus 1 minus tan square theta. Sorry, this is x is what you have to put. You have to replace x as tan theta. 1 minus tan theta by 1 plus tan square theta. So you know 1 minus here tan square theta is what? Sin square by